A stone falls. Everyone knows what happens. Almost nobody agrees on why. General relativity gives a beautiful answer. Spacetime is curved by mass, and the stone simply follows the straightest available path through that curvature. Nothing pulls it. Temporal rate ontology accepts that nothing pulls it, and then goes further. Nothing curves either. There is no fabric to bend. Start from a different foundation. Do not begin with space, or with a manifold, or with a metric. Begin with succession, the bare fact that one event gives way to another, in an order that cannot be reversed. That is the primitive. Reality, on this view, is a directed acyclic graph of events, each one continuing into the next. Space is not the stage on which this happens. Space is a summary we extract afterwards. Now ask one question of every event: in how many admissible ways can it continue? Call that number omega, the continuation multiplicity. It is the structural freedom of the event. A high omega means many futures remain open. A low omega means the event is hemmed in, with few ways forward that the structure will permit. Everything that follows is a consequence of this single number varying from place to place. So what is mass? In this framework, mass is not a substance that produces gravity. Mass is a persistent coordination constraint on event succession. A massive body is a large collection of events that must keep a fixed relation with one another, moment after moment, in order to remain that body at all. Maintaining that relation costs something. It forbids continuations that would break the coordination. So in the neighborhood of mass, omega falls. Fewer futures are admissible there. If fewer continuations are admissible, then succession itself cannot proceed as freely. This gives us the temporal rate, tau, how fast succession actually advances at a location. The rate is fixed by the multiplicity, tau is a function of omega. Fewer admissible continuations means a lower rate. Near mass, tau is low. Far from mass, tau approaches its unconstrained value. This is not a claim about clocks reading differently. It is a claim about the rate at which events can actually succeed one another. The constraint parameter lambda, which appears throughout the formalism, turns out to be nothing other than the inverse of this rate. And here is the point that does all the work. Mass does not create a force. It creates a slope. A gradient in the rate of time, running from the fast, unconstrained region far away, down into the throttled region near the body. The lattice of clocks is not decoration. Each one is ticking at the rate its location permits. Now the principle of maximal freedom. And here we must be careful. No individual event chooses its own branch. Nothing is deciding, locally, to head toward more freedom. Instead, the principle operates on whole histories. Among all the histories the structure could realize, the one that is realized is the history that preserves the greatest continuation freedom overall. In the continuum limit, that global selection shows up as a purely local drift, down the gradient of tau. The acceleration comes out as minus c squared times the gradient of the logarithm of tau. That drift is what we have always called falling. Does this reproduce the physics we already trust? In the weak field regime, the logarithm of the rate is simply the Newtonian potential divided by c squared. Substitute that, and the acceleration reduces to minus the gradient of the potential. Newton's law reappears. Not as a separate law, and not as an approximation bolted on afterwards, but as what the rate gradient looks like when the constraint is gentle. And curvature? Write down the metric that would reproduce this rate field, and you recover curved spacetime, exactly as general relativity describes it. The geometry is correct. It is powerful. It is also derived. On this account, spacetime curvature is the bookkeeping. It is a representation of the underlying constraint structure, not the cause of anything. So here is the entire causal chain, in order. A coordination constraint reduces the continuation multiplicity, omega. Reduced omega lowers the temporal rate, tau. Spatial variation in tau produces a gradient. That gradient appears as gravitational acceleration. And the metric we write down to reproduce it is the derived spacetime geometry. Constraint, to multiplicity, to rate, to gradient, to acceleration, to geometry. Read it top to bottom, and you have gravity, with no force and no fundamental curvature anywhere in the chain. Gravity is not a force. It is not a curvature either. It is a gradient in the rate at which time can happen.